This is another virtual experiment. This one is for investigating the magnetic field produced by a coil. And here we have on the left is a coil. It has various taps on it, so you can select the number of turns you want to investigate. In the middle is a magnetometer, which is just like a compass. The north-south part of it is parallel to the left wall going towards the projector. This is to make the needle that we are going to take our readings off at right angles. This just makes it easier to read. And over here we have a power supply. This power supply will let us set the maximum number of amps available to the circuit and the voltage. We can read what amps are actually in the circuit by using the multimeter here. You can see that these are all connected in series. So we might proceed like this. Select our number of turns as being 2. Go to the power supply unit. Switch it on by clicking on the output button. Then select a maximum current, which can be fairly arbitrary. And then by adjusting the voltage, we can actually adjust the amount of current in the circuit. So here we'll take that to about close on an amp. And if we now move around and have a look at the magnetometer, we can move in on that, and we can actually zoom in to get a good reading. You can just see that swinging very, very, very gently. The deflection is from 90 degrees, so you can see that deflection is about 25, 26 degrees. And if you were to change the number of windings at this point, I'm still zoomed in quite a bit, which makes it a little bit harder to move. Should have zoomed out really. Let me zoom out a bit, that makes it easier. And then go down to one winding. Move back round to the magnetometer. Let's see that swinging a bit more. Zoom in. You can get a really accurate reading just by lining up on it accurately. Okay, so you can do this, and if you plot the amps against tan of the deflection, that's tangent of the deflection, from that gradient you can calculate what the local components, horizontal components of the Earth's magnetic field is. So you can use this not only to do that, but to get the variation between the ampage and the power of the force of the magnetic field, and the number of turns in the force of the magnetic field. And as a bonus, you can calculate the horizontal components of the Earth's magnetic field. Okay, thank you very much.